Greetings, this is Frank Coe, and I'd like to do a demo for series parallel circuit analysis. And let's begin by working out some schematics that show some very interesting relationships and how we go about simplifying these circuits. So the fundamental basis for simplifying the circuit is this. We will simplify, try this again, dyslexia, simplify via redraws. Okay, so we're going to take this very first circuit and we're going to redraw this. You are asked to find the equivalent resistance between the tap on the left-hand side of the circuit based on the relationship of what you see here. So in the redraw, you want to place your eyeball as far away from the point of measurement as possible. So that would put, let's say, at this corner, and as you're looking at the circuit from this particular corner, you see a wire with two resistors attached. Is there anything else attached to these two resistors in the circuit path before they attach to point A and point B? No. So it looks like these two resistors are probably going to be in parallel with each other. So a redraw could look something like this. Let's take this one step at a time. Let's go ahead and make this R equivalent. Here's your taps, and let's go ahead and attach over here, and we have this, and we have this to here, and then we have these two guys that become this. Could we call this REQ1? That is equal to your 470 ohms in series with your 200 ohms. And if you put 470 in parallel with 200, you should end up with 670 ohms. So let's go ahead and do this. This will be 670 ohms. Now, we still have in the circuit the original 270 ohm resistor and the 220 ohm resistor. So in another redraw, if you take this one more step, A and B, we could see this relationship. You would have REQ between these two taps, and then here is point A, and we will do this guy here and this guy here, like so. This is my REQ1, and this is my REQ2. And it turns out REQ2 has 270 in series with 220, so that looks like we should have, let's go to here, 490 ohms, and then 670 ohms over here. So your REQ2 is equal to the sum total of 270 plus 220 ohms, and that's what gives us the 490 ohms in this branch. One more step and we're done. So it looks like your REQ, which most of us would call R total, is nothing more than, between these two taps, right here and right here, the parallel relationship of REQ1 and REQ2. So your R total is equal to 490 in parallel with 670. And so when we go to do this, let's take a moment and do the calculation. Okay, you should have been able to calculate the parallel relationship between 490 ohms to 670 ohms and realize that your total resistance in this case works out to be 283.02 ohms as we round to the hundredth. The digits after the decimal point compel us to round to 0.02 ohms after the decimal point. All right, cool. That was the first circuit. Now let's take a look at what we're going to do with the second circuit. In the second circuit, let's go ahead and again, we will simplify our circuit by redrawing, and we can probably do several steps at the same time because it looks like we've got 3 branches that are in parallel with each other. So we will just go ahead and do 3 branches simultaneously. The very first branch we will keep as is. This is 3.9 ohms. And then over here we have another branch. And these 2 resistors in series, the 11 plus the 15, gives you 26 ohms. And then the third branch coming out here, a single equivalent resistance. This will be 30 plus 47, which will give you 77 ohms. Double check your math. 30 plus 47, 77. 11 plus 15 is 26 ohms. 3.9 stands on its own. So now we're going to calculate our REQ, which is the same as your R total, and we'll do one more redraw, and that one more redraw will look like this. It shows that your RT is really going to be 3.9 in parallel with 26 in parallel with 77. And so your RT will calculate to be, take a moment and do so. Okay, if you've been patient and calculated carefully, you should realize that your R total will work out to be 3.25 ohms. And is the sum total less than the lowest ohmic branch of the 3 branches that make up this intermediate parallel circuit? All right, so we will go ahead and do a final draw on that. So my R total is my REQ, and we have a singular resistance right here of 325 ohms. 3.25 ohms. There we go. Cool. All right, let's take a look at the next one. All right, this one looks fun. Pardon the small type, but I think you can work this out. We have a 10K ohm resistor on top, 12K, 15K, 18K, 22K, 27K, 33K, and a 15K. So we're going to dissect this piece by piece and combine where we can, step by step. So why don't we go ahead and combine the banks first. We have a 2 resistor bank up here, and then we have a 3 resistor bank here. So as we go to do our redraw, my REQ would look like this, come up, and we would have a original 10K ohm resistor at the top. We would have, going down on the bottom, an original 15 kilo ohms over here. That's a kilo ohms. So let's put in a kilo and the omega. And then we come over to here. We will have an equivalent resistance. We have an original resistance here of 18 kilo ohms. And then we come over here and make the attachment. All right, so we happen to have a resistor here and a resistor here. So we can call this REQ number 1, call this REQ number 2. And so REQ 1 would be the parallel relationship of 12 kilo parallel with 15 kilo, and then REQ2 would be 22 kilo in parallel with 27 kilo in parallel with 33 kilo. So let's go ahead and take a moment and calculate those fellows. All right, so if you've been very diligent and careful in entering your values, you should have an REQ 1 that is going to be less than the lowest ohmic branch between these two branches, something less than 12K, and you should be able to calculate that this works out to be 6.67 kilo ohms. Kilo ohms, there we go. And you should be able to calculate that the sum total of these three branches using reciprocal method to do the total will work out to be less than the ohmic branch of the lowest one, which is less than 22K. And if you've done this carefully, you should be able to determine that this works out to be 8.87 kilo ohms. Fantastic. And you would double check each of those calculations, make sure you're happy with 6.67 kilo, make sure you're very confident with 8.87. Now that you've done your due diligence and double check those values, you find out that your R total is equal to the series 1, 2, 3, 4, 5, the 5 series resistors. So how do you find the total of 5 series resistors? You simply add all of them together. And when you add all of them together, let's go ahead and draw the REQ for this. REQ, which is our total. Tap here, come down here, here, and why don't you take a moment and do the calculation for our total for this particular circuit. All right, you should be able to determine with very careful addition that your R total works out to be 58.54 kilo ohms. Okay, so double check that. Make sure you're happy with 58.54 kilo ohms, and we can move on to the next schematic. Cool. All right, here's another one, and again, pardon the resolution of these values. So let me read them off to you. We have 1.8 kilo up here, 2.2 kilo, 3.3 kilo, 1 kilo, 1.5 kilo, 1.2 kilo, and 2.7 kilo. So let's go ahead and do our redraw and chunk this guy out. As you approach this, combine your banks into singular resistances, and let's see what we have left. So we have an REQ, which is what we're looking for. Go ahead, come up, and bring this over. We will have a node here, an original 3.3K ohms over here. Come down. And then down here, we have an original resistor of 2.7 kilo ohms to a point, and we will go ahead and bring in here and here. And so my REQ1 is made up of 1.8 kilo in parallel with 2.2 kilo. My REQ number 2 down here is made up of 1K in parallel with 1.5K in parallel with 1.2 kilo ohms. So let's go ahead and take a moment and work out those calculations. As you're working out those calculations, I'm going to do the next redraw. So REQ right up here, this to here, to here, and this guy comes over to here. Okay, 3.3 kilo ohms. We have 2.7 kilo ohms, and we're going to fill in the values for these equivalent resistors here and here. Let's see what that works out to be. So REQ1 and REQ2. So take a moment and do those calculations, please. Okay, you should be able to have confidence in calculating this twice, that our EQ1 should work out to be 990 ohms, and our EQ2 should work out to be 400 ohms. Now, for your R total, as would appear for this particular circuit, you happen to have 4 resistors that are in a single current path. So to find your R total in this particular case, you would simply sum. So R total is equal to 990 plus 3.3 kilo plus 2.7 kilo plus 400 ohms. So what do you calculate that to be? Take a moment and do that, please. Okay, after having double-checked your calculations twice, you should have the confidence that you have determined the R total correctly, and that value should work out to be 7.39 kilo ohms. There we go. That's what I want to say. 7.39 kilo ohms. And the total final circuit, if you wanted to redraw that, would be simply REQ. And here we go, where that is this. Okay, and that concludes our brief discussion on how to resolve your R totals by using a method that we call redraws. All right, we are redrawing our circuits and simplifying them in each step from 4 resistors of the first circuit down to 3 resistors, down to 2 resistors, down to a singular total. Here we had a total of 5, down to 3, down to a single total. Here we started off with many and resolved this bank into an equivalent resistance, this bank into an equivalent resistance, and we see a simple series relationship here down to a simple RT. Here we happen to have 2 banks, so we combine the resistors of the banks as I've done in green. We have an equivalent resistance here, another equivalent resistance, and we see we have 4 in a single line, and these 4 are in series, which gives us a total of 7.39 kilo ohms for our total. Fantastic.